Hello everybody, this is Dr. Christopher White, and in this video we're going to be talking about an introduction to geologic cross-sections. Okay, so what are we doing? Well, in this lab we are going to be producing a few geologic cross-sections. So a geologic cross-section is essentially a prediction of what is happening to layers of rock underground, because obviously we can't see what's happening underground. Now, we can do stuff like we can take, seismic images, and we can drill boreholes to see what's happening to rocks underground, but those options are extremely expensive, and so most of the time geologists can't use them. So if geologists want to know what's happening underground, the most common way of doing so is to use a geologic cross-section. So how does a geologic cross-section work? Well, now, if you remember, we go back and we think about the lecture for a second. As part of the lecture, we discussed how when we have a layer of rock on the surface of the Earth, we can take three measurements, can't we? The dip angle, the dip direction, and the strike. Okay. Now, the dip angle is the angle at which that layer of rock is dipping into the Earth. Okay. So if we look at this picture down here, we can see we have this layer of rock here. And we can see when this portion of it is going to be visible to us if we're standing on the surface of the Earth. And the dip, by the looks of it, is probably something like, 20, 25 degrees. So this layer of rock is dipping into the Earth at about 20, 25 degrees. Now, obviously, we can see the rock here, but as soon as that layer of rock goes below the surface, it's gone. We can't see it anymore. And obviously, so the only way we can work out what's happening to it is making a prediction based on the measurements we took on the surface of the Earth. So we'll use the data we collected here on the surface of the Earth, and we will try and extrapolate the path that the rock takes underground. Okay, so I hope that's a reasonable explanation of what we're trying to do. Now, then what we'll try and do is, normally in a geologic situation, there won't just be one layer of rock, there'll be multiple layers of rock. So we'll essentially plot the paths for multiple layers of rock, and from that we'll produce an image of the subsurface, which we call a geologic cross-section. And of course, a geologic cross-section is very cost efficient, because all you need is a geologist, a ruler, a protractor, and a bit of time. So there's two ways you can do this lab. The first way is you can print it off and you can do the lab by hand. If you're doing it by hand, you will need a protractor. Okay, you probably haven't seen one of these since high school. Now, the vast majority of students do this lab on the computer. So if you go to exercise 1, we can see there's a paragraph here kind of describing what we'll be doing. I'm not going to read it because we're just going to discuss it. So here's the map. Here's a diagram for exercise 1. Now, as you can see, once again, there's more information here explaining exactly what you have to do. Okay, so before we go any further, the first thing I need to point out is this. When it comes to doing your diagram on Word, it's very difficult, because Word's drawing options are very, very clunky. They're not very good. So in order to make your drawing your diagram easier, what you should do is you should select the image. So just click on it. Then copy the image, Control-C. And then you should go to a program like PowerPoint, in which you can draw more easily. Or you can put it in something like Corel or another drawing program. So I'm going to paste the image, Control-V. And here is the image that we just had from the lab. Now, the one thing I would say is don't resize the image. Keep it this size. Okay, just going to make it a bit easier when you drop it back into the lab in a few minutes' time. So, right, let's just zoom in for a second. So here's our map. So we can see our map consists of 5 layers of rock. 1, 2, 3, 4, 5. And we have these black lines here. Now, these black lines represent the boundaries between each layer of rock. So essentially, they represent the bedding planes. So each of these boundaries, as you can see, will be dipping at 25 degrees. Because if the layer of rock here and the layer of rock here are dipping at 25 degrees, well, the boundary must also therefore be dipping at 25 degrees. Now, if you look at this diagram, you'll notice that this layer of rock and this layer of rock do not have a dip and strike symbol. That is perfectly normal for geologic maps. It happens quite a lot. You can take a measurement here, great. You can take a measurement here, you can take a measurement here, but for these two layers of rock, they just couldn't find a location where they could take a measurement. Now, it doesn't really matter though, because we know this layer of rock is at 25 degrees. We know this layer of rock is at 25 degrees. And so we know that these two layers of rock must also be dipping at 25 degrees. I mean, it's common sense really, isn't it? Now, because we know these layers of rock are dipping at 25 degrees, it also means the contacts between them will be dipping at 25 degrees. Okay? Now, what we're going to do then is when we do our geologic cross-section, we are going to be plotting the position of these contacts between the layers of rock. That's what we're going to be drawing. We're going to be predicting where those contacts go underground. Now, the other thing you'll notice is we have this line here. Okay? And at one end it says A, and at the other end it says A prime. So this is our line of section. This is the line essentially across the world which we have decided to draw our cross-section for. Okay? So when we produce our cross-section, it's a cross-section just for this line. It doesn't work for up here, doesn't work for down here. Our cross-section is exclusively for this line here. Okay, so what's the first thing we do? Well, the first thing we do is we also have to realize, because I forgot to mention it, that when we are worrying about the position of these bedding planes, okay, these contacts, we are worried about their position when they cross the line of section, which is right here, right here, right here, and right here. Okay, so when we do our diagram, we're worried about this point, this point, this point, and this point. We're not worried about these contacts up here. We're not worried about the contacts down here. It's where they cross the line of section. Please remember that. It is where they cross the line of section. Okay, so what are we going to do? Well, we're going to come up here to Insert, then we're going to click on Shapes, and then we're going to draw a vertical line. Okay, done. And I am going to make that vertical line red. So what am I going to do with this vertical line? Well, this vertical line is going to act as a guide. It's going to tell me where to draw my diagram, where to position my bedding plane. So what I'm going to do is I'm going to move it around. Now, can I just point out, might notice as this line is moving around, can you see how it's jumping a set space each time as I move it to the right? It's jumping at a set distance. Now, this is because this line is snapping to a grid. So there's an invisible grid here that you can't see, and the line is snapping to it. It's moving using that grid. So it's jumping from one section of the grid to the next. In order to stop that happening so you can move the line freely, you need to press down the Alt key, ALT. So press down the Alt key, and then all of a sudden you can see you can move the line around without it snapping to that grid, without it moving in those jumpy, moving in that kind of jumpy fashion. So okay, we're going to take our red line and we're going to position it so the end of it falls right here, okay, where the bedding plane crosses the line of section. Okay, and now I'm going to copy and paste this line 3 more times. I'm going to do the same thing here. Now remember, I'm holding down the Alt key. There we go. I'm holding down the Alt key again so I can move it where I want to. I'm going to put it there, and I'm moving this with the Alt key again, and done. Okay, as you can see, this line here and this line here are kind of below the topography, so I'm just going to resize them. I click on the line, and I'm just going to make them so that the end of the line falls on the topography there. There we go. Okay, so our diagram is taking shape. So these lines essentially are telling me, right, this point here is this point here on this topographic section. Okay, so what's next? Well, we know this bedding plane is dipping, so it's angled into the Earth at 25 degrees. So the next question is, what direction? Well, the dip direction is going to tell us that. So if you look at the dip and strike symbol, we can see the long part of the dip and strike symbol, well, that's strike, and this smaller portion here, that's the dip direction. So we can see the dip direction is pointing towards A prime. So that means our layer of rock is going to be dipping down like this towards A prime. Okay. So how are we going to draw our layer of rock? Well, remember, we're going to draw this contact. So we're going to go back to insert, back to shapes. We're going to draw another line. Okay, so we're going to select line, and we're going to draw this line. Okay, there's our line. Now, we are going to draw a horizontal line. There's a reason we drew a horizontal line. Okay, so don't forget that horizontal line for this bit. So we're going to select our line. We're going to go to Format, and then we're going to come over here where it says Rotate. I'm going to click on Rotate, and it's going to say More Rotation Options. So we click on that, and here you can see it says Rotation. So it says 0 degrees right now. So what we're going to do is we're going to type in 25, which is our dip. Going to hit Close, and all of a sudden, bang, this line is now dipping at 25 degrees. Okay, so we know this bedding plane intersects our line of section right here, and this corresponds to this point on our diagram. So we're going to hold down the Alt key again so we can move it where we want to, and there. Okay, now you might notice that this line is not long enough. This line should go all the way to the bottom of our diagram here. So how are we going to fix that? Well, we're going to fix that by holding down the Shift key. So we're going to select it, select the line, press down Shift, and then we're going to extend the line. You'll notice how Shift means the line just gets longer without it wiggling around all over the place. So we end up with a nice line, and we never lose that 25 degree setting. Okay, so now I'm going to copy that line again, holding down the Alt key when I move it, don't forget, and then I'm going to draw the end of it right there. Now I'm going to hold down Shift again, and I'm going to resize the line. There we go, so it's the right length. Okay, select the line again, copy, paste, holding down Alt again. There we go, move it to the right position. Now hold down Shift so the line doesn't wiggle around. See, I can move the mouse pointer around as much as I want, but the angle of the line isn't changing. We can just adjust the length. That's all we can change. Okay, there's that line. And copy and paste. Now holding down Alt again. Here we go, position it right here. And then hold down Shift. Oh, that went a bit wrong there, didn't it? Let's try that one again. There you go. Good. And that's it. Now we have a diagram of what's happening to our layers of rock underground. Okay, so this is layer QR, this is layer AND, this is layer GS, this is layer JF, sorry, and this is layer JD. And it would be helpful if you guys, when you have a second, just label these layers of rock. Okay. So what are we going to do with this diagram now we've got it? Well, we're going to zoom out for a second now. Okay, so now we have our diagram, we've drawn on our layers of rock, and we are looking like a genius right now. So what we're going to do is we're going to select everything, and we're going to right click on it, and we're going to go to group, and we're going to group it all. That just makes it easier. That means when we move this around, everything stays together now. We don't have lines being left behind. All right. So now we're going to go to copy. We're going to copy it. So we're going to do, in my case, Control C, which is copy. And then we're going to go back to our lab. And then we're going to delete this diagram. And then we're going to come, well, you can just Control V it. So that's the diagram we took and we produced in PowerPoint a second ago. Okay. But I'm a bit weird. I prefer to do Paste Special. And I drop it in as a PNG image. because the resolution's slightly better. There we go. And so that's exercise number 1 done. Alright, I think we did pretty well there, don't you? So, okay. So, let's move on to exercise number 2. Now, exercise number 2, as you can see, we just have one layer of rock on the top here. And we can see that this layer of rock has this circle with a cross in it. Now, if you remember from the lecture, this means we have horizontal bedding. It means the bedding doesn't have any dip. It's completely horizontal. So the dip is 0. So the question then becomes is, well, how do I use this information to draw a diagram of the subsurface? Well, it just so happens that on a geologic map, you will also be given something else which is going to help you, and that's the stratigraphic column. So the stratigraphic column is going to put the layers of rock in which are displayed on the map in the correct order. Oldest at bottom, youngest at top. So this means you know the sequence of rocks. So if I look over here, I have my stratigraphic column. So I know under this layer, which is MK, I know there will be layer DJ, and below DJ there is going to be layer VB. Okay, good. So what else do we know? Well, based on the evidence that we have, we can also say that, well, layer MK is horizontal. That would suggest that DJ and VB will also be horizontal. Now, in terms of calculating how thick they should be, you can do that, but it requires, requires a little bit of funky math, and it requires you to, have a slightly better map with other stuff going on. So, this particular map I've drawn here, you can't work out how thick MK, DJ, and VB should be. So we're just going to cheat, and we're going to guess. Okay. Now in this case, as we're just drawing some horizontal lines, I think we'll just use Word, and we won't worry about going over to PowerPoint. So in terms of drawing horizontal lines in Word, we're going to go to Insert, then we're going to go to Shapes, and then we're going to click Line. And as I said, we don't know how thick the layer should be, but so I'm just going to go there. And I'm going to draw a horizontal line straight across. There, done. And so this is going to be layer MK. So now I need to do the bottom contact of DJ. So I'm just going to say right there. And done. Okay. So, okay, not perfect, I admit. But now we have layer MK, DJ, and VB. And so even though we can't see these layers, we can use the stratigraphic column to predict or know that they are there. And we can then assume, based on the dip of layer MK, that they too will have the same dip. Okay, now that's not always true, but if typically you would know DJ and VB may not have the same dip as layer MK maybe, but you would know that because you had been to other locations which would be off the edge of the map, so you couldn't see that data. But based on the data we have here, it's a relatively safe assumption to say, right, MK is horizontal, so DJ and VB will probably also be horizontal as well. And so when we draw them, we'll draw them as horizontal beds. And once again, we can't calculate how thick they are. There are methods we can use, but once again, it requires you to have a much better map showing you a much larger area. So unfortunately, this map showing you this very small area doesn't give us enough data to actually work out how thick these layers should be. So once again, we are just guessing. Okay, so that was exercise 2. So now we're going to come on to exercise 3. Now this is getting a bit more complicated all of a sudden, because you can see we have 1, 2, 3, 4, 5, 6, 7 beds of rock. And you can see that these 3 are dipping towards the right, so they're dipping towards A prime at 45 degrees. These 3, on the other hand, are dipping towards the left, so they're dipping towards A, also at 45 degrees. Another thing you'll notice is if you look at the labels for the rocks, well, JB, JB, WD, WD, YM, YM. So if you remember when we're talking about anticlines and synclines, what did we see? Well, we saw essentially layers of rock running parallel to each other, and we would see the same layers either side of the feature. So this would suggest that this could be an anticline or a syncline. All right, so what are we going to do? Well, we're going to take the image. So Control C, we're going to copy it. We're going to come to PowerPoint and go to the next slide. Then I'm going to paste it. All right, so here we go. Now here's our line of section. So we're going to be drawing our diagram based on where the bedding planes here cross the line of section. So right here, 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 and here. All right, so once again, insert, shapes, line. Just going to put a horizontal line there. And just like before, could turn it red. So now I'm just going to use the Alt key to get them in the right position. Okay, so remember, as I do this, I'm holding down the Alt key so that I can move the lines to where I want them to go. And then my next thing is I'm going to resize the line so the red line finishes exactly on the topography. Okay, great. So now we're going to draw our beds. So once again, we know that this bed is at 45, this bed is at 45, this bed is at 45. We know that this bed is at 45, 45, 45. So we know that these bedding planes here between these layers must be at 45 degrees because that's the angle of the layer of the rock. So this one's at 45, this one's at 45, this one's at 45 towards A prime. We know that this one, and this one will be at 45 degrees, but they will be dipping towards A. Okay, so let's draw our diagram. So once again, insert, shapes, line. Here's our horizontal line, okay, which we are going to color black. And just like before, we're going to go to rotate, more rotation options. And we're going to go to rotation and we're going to put in 45. Close. Okay, so there's our boundary. Now, as you can see, this boundary at the moment is dipping down towards A prime. So we're going to use it for this data over here. Okay, so remember, when we move around, we hold down the Alt key so we can move it where we want to. Okay, once we have it in the right position, if you want to extend it, we extend it by holding down the Shift key. Okay, and then we're going to do the same thing for the other two layers. Great. Okay, so we've drawn this boundary, and this boundary. All right. So now we have to do these boundaries over here. So let's get on it. All right, so this time we are going to insert, shape, line, come across here like so. All right, once again, I'm going to make that line black. Now we're going to go to rotate, more rotation options, and here we have our rotation. Now remember, we put in 45 degrees last time and it made it dip down towards A prime. So what we're going to do now is we're going to take 360 degrees minus 45, and that will make it dip in the opposite direction. Okay, so we are going to do 315 degrees. Okay, I'm going to hit close. See, the line is now dipping at 45 degrees, but in the opposite direction. So now it's dipping towards A, which is exactly what we want for this bed, this bedding plane, this bedding plane, and this bedding plane. Okay, so let's do this. Let's put it in the right position. So this one goes here, and now we're going to extend it until it hits the bottom. Now we're going to do the same thing. Remember, when I'm doing this, I'm holding down the Alt key. When I'm resizing, I'm holding down Shift, holding down the Alt key again, and when I resize, I hold down Shift. And you're thinking, what is going on? And the answer is, well, let's work it out. Well, what we can see is, let's think about layer JB here. It's dipping at 45 degrees. Here's JB over here, dipping at 45 degrees. This layer is dipping at 45 degrees towards A prime. This layer is dipping at 45 degrees towards A. So I have myself a trough, don't I? Which means I have what feature, an anticline or a syncline? Think about it for a second. Anticline is an arch, syncline is a trough. This is going to be a syncline. So what's happening is JB is starting over here, it's going underground, it's turning, it's bending, sorry, it's, not really bending. Bending was a terrible choice of word, ignore that. It's coming underground, and then it's coming back up the other side. So essentially what we have is we have ourselves a trough, don't we? So the layer is going to come down here, then it's going to come round and up. So we're going to have a U shape. So what we need to do now is we need to resize these lines to take that into account. So the first thing is we're going to resize this line and this line so they both meet. Okay, so let's do that. Now remember, I'm holding down Shift. So I'm going to resize one there and one there. Okay, good. So now I'm going to resize these two lines until they meet. Holding down Shift, this one goes to here, and this one goes to here. Now it's not a perfect job, granted, but you guys can refine it a little bit. And now all of a sudden we have the shape, don't we? So here's JB, it comes down, it comes round, and then it comes back up the other side. And so you can quite clearly see our syncline, can't you? Now in the perfect world, you would draw this by hand, you'd kind of have a bit more of a smooth curve. Because we're drawing it on a computer, obviously we have this very sharp angle, but you get the basic idea. So you can see, just by having 6 pieces of data, we've managed to work out that these layers of rock form a syncline. I think you can agree that's actually pretty good for, just a little bit of information. So what are we going to do? Once again, we're going to select everything. We're going to click on the image and go to group, and we're going to group it all together. So now, once again, it can move all as one unit. We're going to copy it. We're going to go back to the lab. We're going to delete the old image because we don't want it anymore, and we're going to paste in our shiny new completed syncline. Good work, us. All right, so what's next? Well, next is exercise number 4, which you will do. I'm not going near it. Okay, so another thing we're going to do is we're actually going to take a break. So this is going to be the end of part 1. Luckily there's no code word, so don't panic. So once again, stop the video, get a drink of water, quick walk around, do exercise 4, okay, then come back and watch part 2. All right, see you in a bit.